Hello, today we're going to be talking about volcanoes part 2. The basic anatomy of a volcano. We already know there's a magma chamber at the bottom where magma collects from the mantle, and this magma is very liquid, and eventually it'll rise up through the crack in the crust and come up through the vent, which we also call the conduit. Okay, and it'll come out through the vent, and here we see that there are smaller vents that form on the sides of this volcano. Here, this one stops at this rock formation. This rock is formed by lava, and that is called a sill. And then the one that continues through the vent out another exit is called dike. Now remember, magma when it's underground is called magma. Once it rises above the crust, it's called lava. So here you can see over time there have been different layers formed, and in this volcano we have the lava layers that are the darker layers here, and then we also have the ash layers that are the lighter layers here. And each side of the volcano is called a flank. So there's a flank on this side, oops, and then there's a flank on this side here. And those cones that form outside of the main cone are called parasitic cones, like parasite, and a crater forms in the middle here. This particular volcano is currently erupting, and it has ash and cloud that's erupting out of the vent. Sometimes it's just lava flow. So in this instant, the ash and cloud will form an additional layer on top that will be an ash layer here. So this type of volcano is called a stratovolcano. We're going to talk about that later. As I said, there's different types of volcanoes. There's 4 types. One is called a shield, and it's looks just as it's called. It looks like a flat shield. So in this picture here, you can see there's a shield volcano. And this is Mount Loa in Hawaii. Shield volcanoes generally form along divergent plate boundaries, and they also form at hot spots because it's a very slow flowing magma that's coming out, and it's forming a flat volcano because of its slow flow. We also have cinder cone, and we have that's basically made up of mostly ash. We're going to talk about that. And we have the composite or the layered volcano we saw in the previous slide. This one is a composite volcano here, Mount Hood. And then we also have the rift zone volcano, which is formed at divergent plate boundaries like this. And Mount Kilimanjaro is one of those rift volcanoes that my family and I will be climbing this summer, so I'm looking forward to doing that. So again, classified according to shape, and the shape is determined by what type of material erupts from the volcano. Shield volcanoes, again, are built from many slow, steady lava flows. Because it's a slow-flowing lava flow, it forms gentle sloping sides. It can be huge, like the volcano here. It has quiet eruptions, so the eruptions are just slow-flowing, pretty much on and off regularly. It's a low silica magma, which causes it to be less violent than higher silica magma. And this is Mount Loa, picture Mount Loa here. Cinder volcanoes, cinder meaning ash, are steeply sided irregular volcanoes. They're built from rock and ash, so you can see how steep it is on its sides. Okay, so it has more violent, explosive, high silica eruptions, which cause this rock to quickly form and build upon itself, which is why it has the steep sides. Okay, so the rock and ash burst up into the air and fall back to the earth after the eruption around the vent, as you can see here. Then there's the composite volcano, like the one we had seen earlier in the anatomy of a volcano. It also has steep sides, and they're symmetrical, meaning it's kind of similar steepness all around, and they're cone-shaped. They have a broad base because the initial base forms possibly through lava, and then it builds upon that. So they also have layers of lava at times, and sometimes emits rock and ash. So this is what forms the different layers, as you can see here. The darker layers are represented for lava, and the lighter layers are representing ash and rock. So the quieter lava eruptions will form the lava, molten lava will harden and form the rock layers, and then in between we'll have the explosive eruptions, which will emit rock and ash, and that'll layer, and then you will see these striations when you do dissect a volcano. Okay, and it just depends what amount of silica there is. So each layer would either be quiet if it has low silica content, or it would, when it does have higher silica content, it'll have these more explosive eruptions. And there's pictures of these volcanoes here. There's also the rift zone volcano, and it's exactly where it is, what it describes. It's at a rift zone. A rift forms when two plates are divergent. They are moving away from each other. And there's the East Africa rift, where the mountains are formed, and there are a couple of mountains there, including Mount Kilimanjaro, and these are quieter eruptions. So generally speaking, at these rift zone volcanoes, they're more likely to be shield volcanoes. So they're usually at divergent plates where there's rift forming. Again, also mid-ocean ridge is considered a rift zone area, so rift zone volcanoes will form there, such as those that form in Iceland. And then there's the wording crater versus caldera. That can sometimes be used interchangeably, but they do mean two very different things. A crater is a steep-sided depression around a vent. So as the volcano erupts, the lava and ash form the steep-sided wall around the opening, and that is a crater. A caldera is a little different. A caldera is when there has been a mountain formation on top of a volcano, and then the magma chamber explodes, and all the debris explodes up and falls back into the crater, and that top of the volcano has basically collapsed into the crater, forming this large circular depression. And then it eventually, over time, either one of these can fill up with water over many, many thousands of years and form a crater lake or a caldera lake. And sometimes they do, sometimes they don't fill up. But these are the two differences between the crater and the caldera. Crater is a wall that has been built up over time through multiple lava eruptions or ash eruptions, and a caldera has been, the top of the volcano has basically erupted and exploded into itself, collapsed into itself, forming this depression at the top. And that is the end of our PowerPoint for today. If you have any questions, please jot them down and ask me in class tomorrow. I'll see you later. Bye.